you do. Listen, they're very kind of booky and bookish. I've got a faster way, but I want you kind of to explore these a little bit and figure out what that is, and I'll kind of formalize it before we go today, like what is the best way to approach these as far as which one goes where. Because once you figure out which one goes where, like I said, it's usually pretty quick. And then at the very end, I can't wait to show you in certain scenarios, there's an easy button. I'll show that to you too, okay? So hopefully this will be good. Let's try. So don't forget, I'll leave this up here. Don't forget this integral of UdV equals ultraviolet voodoo. Okay, so I'm going to do this. So let's take a look at example 1. And with example 1, I'm going to give you guys a couple of options, and I'll let you kind of figure it out as far as which option you think is the death spiral and which one you think is the good way. So I clearly have two functions, one of which is a polynomial type thing, like just x, and the other one is a transcendental, sine of 6x. And so I'll highlight these two. Here's the first one, here's the second one. So whenever you see a product, an integrand that's a product, and it's a polynomial times a transcendental, that's your cue to think about this integration by parts. Okay, I'll say it again. Anytime, so I'm using a really broad term, anytime, so like this is a bold statement. Anytime you have an integrand that is a product, right, this is x, I'll try to squeeze this in there, x times sine of 6x, and the product is made of a polynomial sort of thing, you know, like x to the third or x to the 2 or x to the fifth or whatever, and also a transcendental, which would be like logarithms, sines, cosines, e to the x, other exponentials, things like that, right? So whenever you have this pattern, is this making more sense?
Yeah.
This is when you'd want to think about, should I do this integration by parts routine? So the question then becomes, how do I want this to go? I'll give you some options here. I usually set this up in sort of a little box, sort of an arrangement. I'll put the u right there. I'll put the dv down there. They're on different levels for a reason. So you could either set this up to be, you could set it up one or two ways. You could say that u is sine of 6x and dv is x, or you could set it up as u is x and, this should be x dx over here. And over here this would be sine of 6x dx. You see how you have to pick, right? Because we're setting it up. We're trying to set it up so that we have this u dv. So if I can figure out my u, and if I can figure out my dv, then all I got to do is plug in the things that need to go where they're supposed to go, do a little antiderivative, and maybe that's it. The formula, right? It's a recipe. Okay, so then in order to do this, don't I need, I don't just need a u and a dv, don't I need a v and a du to go along with this? Okay, so we need to fill out the rest of our little box here, a little table. So if u is sine of 6x, what would you guys guess du is? Wouldn't that just be the derivative of that?
Yes, 6.
There you go, 6 cosine of x, 6 cosine of 6x. And we'll throw the dx over there. We'll just mentally multiply that over. So then, how would we get to the v? If my dv is x dx, what do you think the v would be?
Integrate out.
Not the derivative, the integral, the antiderivative. So what do you think it would be for this one? 1/2 x squared. Agreed. Okay. So then, let's do the other one too, because I'm going to let you guys pick here in a second which you think is the better of the two. So over here, if u is x, what do you think du would be? Say again? 1, and technically 1 dx. So I'm just going to write dx there. And then, this was maybe a little bit tougher. If dv is sine of 6x, what do you guys think v would be?
Negative 1/6 cosine.
All right, there we go. Timmy messed it up, but we fixed it for him, right, with that negative 1/6? Okay. So basically your task for the next moment or two here is this. Deciding whether the setup in the pink box is good or the setup in the green box. Oops, set up in the green box is good. So what I would encourage you to do to make this decision, I want you to look at that uv minus integral of v du and see which one seems to work. Because honestly, the one that's going to work nicely is just going to work pretty nicely. And the one that's not, you're going to start to question and say, oh my gosh, this looks worse. This looks bad. Okay? So the best way to do this is to not just stare at it. The best way to do this is to try ultraviolet voodoo, UV minus integral VDU. Just see what happens. Okay? So play. Try. Ready, go. Pick up your pen or pencil and start writing. We'll settle this. Don't worry about that. I just want you to explore and see if you can come to a conclusion on your own. Which way is better? I hope you guys feel the same way. I feel like it's been a really fun homecoming week.
It's been long.
Honestly, this has been a bad homecoming week.
been
I was
this
very
week.
much to say it.
Why has it been so bad?
I don't even know.
I'm just judging it based on people's spirit and costumes and the
Yeah.
powder puff game was sort of fun.
I don't know if it was also much. Like,
I'm sorry.
that was just expensive.
Okay, I get that. I can buy that.
I don't like the
I don't deal well with losing either. It's a character flaw on my part.
Yeah.
Struggle. I mean, there's a lot of people who struggle with that. So.
It's great.
You guys got smacked. I didn't watch the game.
Don't rub it in, Jack. Don't rub it in.
I got actually.
I was there.
I heard
Got
that.
shoved in the community?
I heard that you
Yeah,
didn't
you
get to
know,
play like all,
Yeah,
Oh,
the
yeah.
games were so like.
which is not how.
Wait, the deans wouldn't?
Miss Passwater was getting on the bench and she was like, you can't just like all the so like.
But that's not how sports. That's not how sports work. So.
Did she like legit say that Megan wasn't allowed to play?
No, she died on play.
Right, that's what I'm saying.
Yeah, she really said like Megan hard out.
Was it just you or was it all of you guys?
My whole team, like all this senior
Why?
on our team got like
So then I was
shoved
just like
over.
bench like.
And like
Cool.
they were all laying on top of us and
So it's
you
this
know, my knee kind of
or.
hurts, but what I'm more upset about is they messed up my spray tan.
The orange has been marred.
Look at
Oh.
right there. What happened?
It has more of a pinkish red
Do you
shade.
see how it's like
Wait.
right there?
She's not as good at the traffic anymore.
Yeah, like how am I supposed to stop traffic if I'm not even completely orange? Like,
Wait, that's V. Wait, hold on. This is D. This is the V.
It's cold.
Has anybody entered a death spiral yet where you've got to this like hopeless
oh,
place
I've
where
been
you
in a death spiral for like 3 years. So.
I don't know, maybe that's an inappropriate term, but it's just like, in a math sense, you just feel like this is never going to end, it's only getting worse. Anybody got there yet on this one? Or maybe you
I'm
picked
so
well.
con-
I don't
I
know.
am so confused.
Did you choose wisely?
Yeah.
Okay.
I didn't know this one.
To quote the Indiana Jones and the Last Crusade, you ever seen that movie?
What a great
He
movie.
chose wisely. He chose poorly. Right at the end.
Yeah, and then the dude like
Like ages.
holy like camera effects of like of
Yes.
yesteryear.
Yes.
And like
But
when
the
they melt.
acting is fantastic.
Oh, absolutely.
It's awesome.
I mean, you can't not love that movie.
It's that's a classic. I think will survive the decades. You know, the
I
centuries
would hope
perhaps.
so, man.
It's just good. I mean,
Yeah.
Sean Connery, Harrison Ford on the same.
Sean Connery is. He's low key one of my favorite actors of all time.
He's got. Doesn't he have to be like in the top 10 most cool people of the history of the world?
If not most cool people, then definitely most cool accents, like at minimum.
True. Yeah. Yeah.
But yeah, I would say so.
I'm glad to hear that you've seen that. Good for you.
Dude, I own all 4.
Nice job.
It's so much fun.
I've seen all of them. I just don't remember most of them. Like I remember the face melting and I remember
Yeah,
a
the
few
face
things.
melting was crazy.
That was
way.
pretty memorable. And the
Wait.
thing with like the guy who reached into their hearts and ripped out their hearts or something.
Ooh, special effects, man. Like Logan said, special effects from like the kind of the 80s, 90s era, maybe late 90s, something like that. I guess there was one like in the 2000s too. The Crystal.
Yeah, Kingdom
Skull.
Skull. Like I own that too, and it was solid.
Yeah, it was good. It's hard to like really replicate the coolness of the originals, you know.
It
'cause
was, especially that. with that much of a time gap.
Yeah, it's hard to go
I mean, I
back.
did it. Oh
The
my
barbershop
God,
movies
yeah.
did
Just
it,
kind
though.
of
The what one?
The barbershop movies.
You choose.
I've never seen those.
Well, the other one just looks
It was like
death.
There's a
early-
gap and
early
they-
90s.
And they were able
Made
to.
two really good ones, and then they released
Going
another one
DX.
like 2 or 3 years ago.
Huh.
Apparently, it was really good.
That's rare. That's cool. Good for them.
Yeah.
Takes some good writing, some good producing. Well, I'll tell you what. Why don't I show you what the death spiral looks like? I'll pick the wrong one, and then I'll pick the right one, and hopefully we get to a good place. Yes, ma'am.
So is the point of it is to get it into the UV minus,
The point of this is to find the antiderivative of x times sine of 6x.
so you keep going with it?
You get to it until you have a final antiderivative plus c.
I forgot my C.
Okay? So the goal, the goal really is pretty simplistic. I mean, it's not easy, but the goal is simply to find an antiderivative. And up till this moment, you would have had to look at something like this and say, Timmy totally messed it up. It's definitely not arcsine. It's definitely not arctan. Flip up. That has no meaning here. What do I do? The answer would be parts. Yeah. Okay, so let me show you. Let's see how close you got or how far away you got. We'll figure it out. So the wrong way here, the choosing poorly would actually be the pink box. This is not what you want to do. So check this out. So Santi, guys, I will give you a way to intelligently approach these here in a little bit, like try to see a pattern here. But let's just look at what would happen if I did this. I would say then that the integral of x sine of 6x dx, that's my integral of u dv, right? So this is u, and sorry I flipped it around, but that's okay. This is dv, right? Equals, or I flipped it around. For the pink box, it's the other way around, right? Yellow is u, dv is red.
Yeah.
So it would be ultraviolet 1/2 x squared sine of 6x. There is nothing wrong with that. Minus voodoo. So this would be 1/2 x squared times 6 cosine of 6x dx. So the issue with this is the wrong way. The issue is not over here. This is no big deal because it is what it is. But over here, don't we have to find the antiderivative of that?
You're gonna do the same thing.
Wouldn't that lead you to another integration by parts? Because isn't it another like polynomial times transcendental? Which, by the way, listen please, that in and of itself is not the end of the world. But if you pay attention to the pattern, if I did that again in the same way to this 1/2 x squared times 6 cosine 6x, wouldn't the polynomial go up a degree? Cubed. And then wouldn't you have another one to do later? And then that time the polynomial would be up another degree, fourth. And so eventually you would say there's no end to this, right? Because the polynomial degree is just going 2, 3, 4, 5, 6, 7, 8, 9, 10. And your answer is just going from here to here to here to here to here to here to here. And you just got to see this happening where it's just not going to work. So if you do see that where you're seeing like the polynomial degree is going up, and your answer just keeps getting bigger and bigger and bigger, and you see that it's only just going to keep getting bigger and bigger, what that probably means is that you picked the wrong UDV. You need to flip it around, and in this case, go with the green box. That make sense? So if I were to get rid of all this stuff with the pink box and just go with the green box, we'll see a much happier result. So same thing. I'm going to set up my ultraviolet voodoo. So it would be x times, I'll just do it like this. I'll clean it up. It'd be negative 1/6 x cosine of 6x minus, don't forget voodoo is bad, the integral of v du. So this would be negative 1/6 cosine of 6x dx. So we're in a similar spot, except now to find the antiderivative of that second term is going to be quite relatively easy for you guys, right? We got to, maybe you deal with the negative 1/6, then you got to remember the antiderivative of cosine is sine, and you get the Timmy messing up the chain rule again, right? But if you do this right, I think we get negative 1/6 cosine of 6x, and it would be plus 1/36 sine of 6x. I think if I'm doing those details right. Right?
Yeah, that's right.
And I know that I'm done because there's no more integrals in my expression. Whereas before, when I was in that death spiral with integration, the integral was never going away, and the polynomial degree just kept on going up and up and up and up, and I got myself into trouble. This was over pretty quick. What do you think? So the big takeaways are these. Here's the two big takeaways. If you can get these two, then the rest for you guys is just details. Here's the two big takeaways. How do I set it up? Like, what's my u and what's my dv? Right? Did I set that up correct, or did I not? And then I just had like total thought loss right there. Sorry.
Brain farts, okay.
Yes. Set it up. Maybe it is. Just like suck the energy right out of my brain. Set it up right. No, I'm sorry. That's the second one. First one is recognize that you need to do this. Right? Recognize that parts is the thing you should do, and then set it up right. If you can do those two things, the rest is just details. So, why don't you guys look at example number 2. This is a nice one. X squared ln of x dx. Can anybody explain why on earth anyone would think to use integration by parts on this particular one?
Because the degree of the outside is bigger than the degree of the inside.
No. I don't think so.
That's a good shot.
I mean, what you said is true, of course, but I don't think that that's the reason why you would do integration by parts. Well, I keep thinking, why on earth would you even think, hey, let's do that ultraviolet voodoo thing? And there being, that's it. It's a product of a polynomial sort of thing and a transcendental. If you have that pattern, you've got to think about using parts, okay? So see if you can identify your u and your dv, and if you can go far with this and get an answer, that's great. Again, to hopefully clarify, please check this out. I want to make sure this is clear for you all. So integration by parts is this. The integral of u dv equals u times v minus the integral of v times du. Okay? So when you set it up, what you're trying to do is you're trying to figure out which of my two factors is going to be u and which of them is going to be dv. Not v. We're trying to... So one of them you'll have to do an antiderivative to get back to the v. Yeah. Yep. Okay. So I'll let you try to wrap up number 2. I can see that some of you are maybe in the last stages of that. Am I right? Or did you guys finish number 2? Looks like maybe you're done.
Oh, yeah.
You done?
I think I may
Okay.
be
We're
going.
just really good at it.
No.
Well, that's great. I'm glad you are. If that's the case, more power to you.
I think that's necessary. But
I could take the
So
test
this-
and now get 100%.
So, Forrest, this might help. Let me do something here. Okay, so what I'm suggesting we do is essentially set up an organizer. Like so. And I'm going to make my u be up here and my dv down here, so that my lower level is like derivatives, upper level is like the antiderivative of the derivative, or like the regular function. Does that make sense? Okay, so have you guys figured out that the pattern is a little bit weird here? Because on number 1, didn't we make the polynomial our u and the transcendental our dv? But in this case, that doesn't work, does it? If you try to set up where the polynomial is u and the ln of x is dv, you get to this point where you have to find the antiderivative of ln of x. And if you're honest about it, you don't know what that is yet. You can actually use parts to do that. So what you got to do here is, if you figure this out, you got to make x squared dx your dv, and your u would be ln of x. This is how this particular one works out, and we'll talk about the pattern here in a second. So du, did you guys get 1 over x times dx? And then v would be 1/3 x cubed. So then I'm just going to plug those things in over here for my ultraviolet voodoo. Those things will just get plugged into the appropriate places. So I can then say this is ultraviolet, so this would be 1/3 x cubed ln of x minus, works out pretty nicely because don't one of the x's cancel out? So then when you finish this off by finding that antiderivative, you get this, and this plus c. So some of you, and I would get it if you were thinking this, like some of you might kind of question this and say, what's the pattern? Because in number 1, we made the polynomial u, and that worked out great. But in number 2, we had to make the polynomial dv. That's how this one worked out great. So what's the pattern? Can I give you the? There is a pattern. There is.
Shoot.
So I'll give you the pattern right here. When you look at your original integrand, look at the transcendental. If the transcendental is natural log, you have to make the u natural log. And the dv would be all the other stuff. Okay? However, if the transcendental is anything other than a logarithm, if the transcendental is something other than a logarithm, you want to make your polynomial the u. That's the pattern. Does that make sense? Look at the transcendental. That'll tell you what you need to know. If the transcendental is not a log, then make the polynomial your u. If the transcendental is a logarithm, then you make your logarithm the u.
Always?
Right there. Yep, you got it.
No
Always.
exceptions.
As far as I know. There might be some exception I don't know about, but as far as the world we live in, as far as what we live in here, no exceptions. Yeah. Okay.
I think I found the easy button.
You think you did?
I feel like I'm like onto it.
When you're onto that example 4? Okay.
I mean, it kind of falls off of you.
You might have found something really good. I'll show you my easy button and we'll see if we can make the pattern kind of be the same.
Can I take a guess, but then don't tell me if I'm right? No.
Take a guess, but don't tell you if you're right.
I'll say yes. So it's
Hang on one second. I want to get you guys going. Let's do example 3. Use that little pattern I just showed you. Do example 3. Try it out.
So it would be d of x equals uv minus u prime v minus u double prime v until you get it down to where your u is x to the 0.
But what if? Okay. I see what you're. I think I see what you're saying.
I don't know how to word it very
it's
well.
like x plus 1 squared.
What? Wait a minute. Why is your transcendental sign every time?
Yeah, good point. Because that's what I got.
I think there should be some changings of the transcendental. Be some sines and cosines.
Sine, cosine.
Yeah, it should be something like that.
Okay, so I'm tripping.
Yeah. But what you're trying to do, Logan, is like you're trying to see a pattern within that, and that's exactly what the easy button is. You're totally right.
Cool. See, I knew I was onto something. I just didn't know what.
So what I noticed is that your V's were just like every step on your little pattern. There were V's every single time, and they shouldn't be. I was wondering how you were going to note that.
Gotcha.
There should be some changing of that, and I was just trying to think about how is he going to note that. Like, what's the symbol going to? It's going to be some integrals, right? And it's like
wouldn't it be just like the integral of the next v?
Yeah, and so then that would be like the integral of the previous integral, so it'd be like an integral of an integral kind of thing.
Yeah.
I was wondering how you're going to make that look. We'll definitely get there, though. I have my own little way of writing
I found
it,
something.
but you have definitely found a pattern, and that is more or less kind of the pattern we're going for.
Yeah.
Cool.
Good.
Yeah, you're seeing it. That's
Feel good
good.
about yourself, dude. Amen. Self-esteem is a big part of life.
Believe it or not, Logan, like when we talk about like real math, that's kind of what real math is. It's like it's using stuff you know to try to figure out something that maybe nobody knows and looking for patterns and thinking, I think this is it. And then either you or someone else pokes holes in your pattern and you're like, ooh, that's not it. And then you go back and you rethink and you think, well, maybe it should be this. And then you kind of work that out and you're like, oh, maybe I've got something there. And then you resubmit to the hole poking, right? And maybe eventually somebody's like, wow, that looks real good. And then maybe you take it to somebody else and then maybe they poke another hole in it or there's some more. It's this process of like, wow, does this make sense? Well, that's actually not right. How could we get around that? And so it's kind of an interesting like playing kind of with numbers and math and logic to make sense of it all. So.
Oh God, there's a lot. There's actually a lot. This one's not easy.
So.
Okay, if y'all would,
A lot of signs to be lost.
I want to make sure I get to the easy buttons. Forrest, can I show you, and then if you still have a question? Okay. So if we're going to follow that pattern that I just shared with you guys, because the transcendental is not a logarithm, I need to make my polynomial my u, and then